This video is over lesson 38, using properties of equality to solve equations, and it's for my pre-algebra classes. So ladies and gentlemen, we have a vocab term here, inverse operations. So inverse operations are operations that undo each other. So I have 4 examples here. You might want to just jot those down real quick, maybe even pause the video. So here we go. So inverse operations, operations that undo each other. So if we have a number and we add 5 to it, what would undo that? Well, what undoes addition is subtraction. So if we subtract 5, it'll undo the plus 5, and so the answer should be n. So if you take a number, add 5, and then subtract 5, you should be right back at n. So what undoes x minus 6? Well, if subtraction undoes addition, then addition should undo subtraction. So x minus 6, but then plus 6, the plus and the minus are inverse operations, so they should cancel each other out, and we should be back to x. And now keep in mind that this only works because we're adding and subtracting the same thing. Just like up here, we're excuse me, adding and subtracting the same thing. Down here, then, if we have a number times 7, what would be the inverse operation of times 7? Well, divide by 7. So that if we take a number and multiply it by 7 and then divide it by 7, we should be right back at A, where we started. And then finally, if division undoes multiplication, it should make sense that what undoes division is multiplication. So a number divided by 8, then times 8, should take us right back to that k that we started with. So that's kind of the idea behind inverse operations. These are two operations that undo each other. So if we use the same number, we do each of these operations, they'll cancel each other out. And so with that in mind, we're going to shift gears here a little bit, and we're going to talk about a few properties, and then this is all going to come together once we get through these properties. So our first property is called the addition property of equality. And you may, on the homework, abbreviate that as the add prop of EQ. So the addition property of equality says if A equals B, comma, so good grammar if you got an if-then statement, if something, comma, then A plus C equals B plus C. And now, ladies and gentlemen, I want to pause here on this property because when you've got things like this, I want you to learn how to read them. So when we say if A equals B, we're not really saying that A equals B. You might be tempted to think that this is a variable that represents a number, this is another variable that represents a number, and so you've got one number equaling another number. That's not really what this is saying. So when we say if A equals B, the big idea here is this equal sign. It's that something equals something else, which means that this is an equation. So when you see this in a property, whether it's this property or a future property, what this is really saying is if you have an equation. That's what it's really saying. If you have an equation, then what? What do I get to do with my equation? So if we come over here, we see A plus C equals B plus C. And this is where we've got to understand a little bit more about this equation here. So A equals B, that A does represent something, that B does represent something, but what do they represent? And they don't necessarily represent just a single equation or a single number. So when we say A equals B is our equation, that could be 2x plus 3 equals 17. And so if I say 2x plus 3 equals 17, then this is my A. Got my glare there a little bit. So that's my A, which means that this right here is my B. And so A and B here, we discover, really just stand for the two sides of the equation. A is really just the left side of the equation and B is the right side of the equation. So if we come back here to our notes now, then what's happening here is I have the left side of the equation where I'm adding C and the right side of the equation where I'm adding C, and it's still equal. And so what this property tells us is you can add the same number. So since we're adding C, it's C on both sides. You can add the same number to both sides. When we say both sides, we mean both sides of the equal sign. And it's still equal. So you can add a number to both sides of the equal sign and it's still going to be equal. And so that brings us to our second property, the subtraction property of equality. And it also has an abbreviation for the homework. This is going to be the sub prop of ec. And so the subtraction property of equality is very similar to the addition property. If A equals B, and now while you're reading if A equals B, again, based on what we just talked about, you should be thinking, though, that if you have an equation, this is really saying if you have an equation, then A minus C, so the left side minus a number, equals the B minus C, the right side minus the same number. And so what we see here is basically the same thing as the addition property, it's just that we're subtracting this time. So that if you have an equation, you can subtract the same number on both sides and it's still equal. Which brings us to our third property. And you might be able to guess where this is going. Third property is the multiplication property of equality. Oops. Multiplication, there we go. Property of equality, and its abbreviation is the mult prop of ec. So the multiplication property of equality, if A equals B, so if we have an equation, which we do, if A equals B, then, and that's kind of a funny looking then that's better, then AC equals BC. And so that one looks a little different just because we can imply the multiplication. So when we say AC, it obviously means A times C. So again, we've got the left side of the equation multiplied by a number and the right side of the equation multiplied by the same number. So if you have an equation, you can multiply both sides of the equal sign by the same thing and it's still equal. Which brings us to our last property, the division property of equality. So the division property of equality is abbreviated div prop of ec. And this one's a little different. This one is a bit different, actually. So for the division property of equality, it does start with if A equals B. So if you have an equation, and then I'm going to leave a space there. We're going to fill that in a second. So there's one more thing that we need in order to use this. So in the others, we just needed to have an equation. This one, you need to have an equation and one thing more. But I'm gonna skip that for just now, and I'm gonna say then A over C equals B over C, because of course fractions mean division. So what we see here again is if we have an equation, then we can divide both sides by the same number and it's still equal. So ladies and gentlemen, this is where we're going to leave the notes behind for just a section. And I'm going to show you a little something. And this is going to be beyond your skills right now if you are in that pre-algebra class. So you're going to have to trust me on this, that what I'm doing is true and correct. So bear with me a little bit. So here we go. Let's say that A equals B. Okay, based on the properties we just learned, we know that we can do things to this, modify this, as long as we modify it on both sides the same. So what I'm going to do first here is I'm going to take A equals B. I'm going to multiply both sides by A. So A times A would give me an A squared, and A times B would just be AB. Okay. So you may not understand why I'm doing that, but understand that the multiplication property of equality tells me that these would still be equal. That's the important part. Is this still equal? Yes. Okay. Because I just multiplied by the same thing. And then from here, what I'm going to do is I'm going to subtract from both sides a B squared. So now this is still going to be equal because all I did was subtract the same amount from both sides. Now you may not understand why I'm doing that, and that's okay. Because remember, this isn't the notes, so this isn't something you're going to do on the homework. Okay. But the point is it would still be equal. All I did was I took my starting amount and I multiplied both sides by the same thing. And now I've subtracted both sides by the same thing. Now I'm going to use a skill where you're going to have to trust me a little bit, that this is a skill that you're going to learn in algebra more. We'll start to learn it in pre-algebra, but you'll learn it more in algebra. But it's a thing called factoring. So we already have enough skills that we've learned about the distributive property that we know that we could factor a b out of this. So if I take a b out of that, that would have to be times a minus b. So that if I were to distribute the b back in there, we'd go back to this guy here. Now over here, this is where you're going to have to trust me. A squared minus b squared, there's a little something you'll learn in algebra that anytime you run into a situation like that, you can factor that as a plus b times a minus b. And I don't expect you to understand that. You're going to have to trust me on that one. All right, so from here, what I'm going to do is I'm going to divide both sides, okay, both sides, by the same thing. I'm going to divide both sides by that a minus b, because I see a minus b on both sides, so that way this guy will cancel and that guy will cancel. This guy will cancel and that guy will cancel. So that simplifies it nicely for me. So if I just take what's left over now, so I divided both sides by the same thing, so it should still be equal, right? So a plus b then should equal just b. From here, what I'm going to do is I'm going to take advantage of what we said at the beginning. We said that a equals b. Now in mathematics, anytime you've got two things that are equal, it means that you can replace one of them with the other. So I'm going to replace this a with what it's equal to, b. So I'm going to get b plus b equals b. And then I can combine like terms. If you have one b plus a second b, that's two b's. Okay. Now I'm going to divide both sides by b. So b and b will cancel and both become 1s. B and b will cancel and both become 1s. So 2 times 1 divided by 2 is 2. And 1 divided by 1 is 1. Hey, look at that. 2 equals 1. And if you think that's true, boy, do I have a deal for you. You can, at any point in time, go ahead and bring me in $2. And if 2 is actually equal to 1, then I will give you back the equal amount of $1. So the same amount of money, right? Because if those things are equal, the same amount of money, right? But I will be in my generosity, I will give you an extra 50 cents. And so you'll actually make 50 cents off of that deal. And I'll do this with you as many times as you would like. I am perfectly happy to take your $2, give you back the equal $1 with an extra 50 cents. Now let's get real, guys. You obviously know this isn't right. And I wouldn't actually take advantage of you like that. But hopefully putting a dollar sign in there really hammers home the point. Something's gone wrong. And well, a lot of this is new to us, and you might be tempted to point out and say, oh, up here there was something wrong because a became a squared, but b became ab. No, 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 no. Nothing wrong with that because all I did was multiply both sides by a. So that's perfectly fine. Over here, all I did was subtract the same thing on both sides. That's perfectly fine. Okay. Factoring is a skill we're allowed to do. We know that. Okay. This was just simplifying. It was just simplifying what was left over after we canceled things. Okay. Replacing the a with the b that it's equal to is called substitution. That's fine. Okay. Combining like terms is fine. Dividing by b on both sides, that's fine. And simplifying it down to 2 is fine. So where's the mistake? The mistake is actually right here. You see, ladies and gentlemen, the trouble is a minus b. Because if a and b are equal, that means this is something minus itself. This means it's 0. And that's where we run into trouble here, is we can't divide by 0. So this brings us now to our notes. So bring your notes back up here. So we had that and there. So if we have an equation and what we're dividing by is not equal to 0, then we can divide both sides by that number and it will still be equal. But as we just discovered, if what we're dividing by is equal to 0, it can lead to some crazy results that are obviously not true. So for division, you can't divide by 0. So you can add anything to both sides, you can subtract anything from both sides, you can multiply both sides by anything, but you can't divide by 0. Okay. So let's talk solving some equations, skip a couple lines there, and let's take a look at x plus 5 equals 12. So if we want to solve this then, I want to get x all by itself. That's what it means to solve this, to isolate that x, get it by itself. So to isolate it, since it's a plus 5, we do the inverse operation. We use the subtraction property of equality and say I can take the right side, or excuse me, the left side and the right side, and I can subtract them by the same number, and it will still be equal. So the left side minus 5 and the right side minus 5. And so that plus 5 minus 5 cancels each other out, and we're left with just x. And then 12 minus 5 is 7. Okay. I'm going to come over here. Let's say we had x minus 7 equals 8. So that minus 7, the inverse operation of subtraction, is addition. So if we use an addition property of equality, we're going to take the left side and the right side, and we're going to add the same number on both sides. Well, in order to cancel out a minus 7, we're going to have to add 7 to both sides. The minus 7 and the plus 7 are inverse operations. They cancel each other out, so we're left with just x. And then 8 plus 7 is 15. Come on down a couple more lines here. Let's take a look at 3x equals 36. So 3x equals 36. So we have 3 times x. So the inverse operation of multiplication is division. And so we're going to take my left side and my right side, and we're going to divide them by the same thing. Now you'll notice here I've thrown them into fractions because as we get closer and closer to algebra, we start to leave behind that division sign. So we're going to write that as a fraction. So we're going to divide both sides by 3. And so times 3 and divide by 3 will cancel, leaves me with just x. And then 36 divided by 3 is 12. And then finally, let's say we had x over 9 equals 6. So same idea here, fractions mean division. So this time though I want to cancel out the division. So the inverse operation of that is multiplication. So I'm going to take the left side and the right side and multiply them both by 9. So my divide by 9, my times 9 will cancel each other out. That leaves me with just x. And then 6 times 9 is 54. So ladies and gentlemen, this is each of the properties being used. However, I want you to take your red pen and put a box around this. Little note here that this is the book's way for work. However, this is not our way. So you're going to see that in the book, but this isn't how we're going to do it. How I'm going to have you do it is actually going to save you writing in the long run. So we're going to do a fair bit of writing just getting this set up, but in the long run, just get rid of that shadow behind my paper there. So in the long run, it'll be shorter. So let's go to the back here, and in the middle, we're going to redo that first equation, x plus 5 equals 12, and I do want that in the middle because we're going to make 2 columns now next to it in red. So the first column, if I can spell correctly, is going to be think. So this is what you should be thinking as you're solving your problem. And then the second column to the right of it is going to be justify. Okay, and so if the book asks you to justify your steps, then the stuff in red here is going to actually become something you've got to do in pencil. So depending on the instructions. So if the instructions don't say to do that, then you can just leave that something that you think about. However, if the directions give you direct you to write justifications, make sure that gets written down as well to get full points. So when we're looking at a problem, we've got that problem. The first thing we should be thinking is we need to copy the problem. And so when we copy the problem, on this line of our work, we're going to find an equation. So in this case, we have the equation x plus 5 equals 12. So if I take that out of my shadow there. So now justifying, why is this equation here? Because it's an equation that was given to us. Given will always be the first justification. That's the problem that was given. So from here, just like we did on the front, we're going to subtract 5 on both sides. But the way we're going to show our work is instead of rewriting this whole thing, rewriting x plus 5 and then putting a minus 5, rewriting 12 and putting minus 5, I'm just going to subtract 5 on both sides like that. So instead of doing my subtraction horizontally, I'm going to do it vertically. And since it is vertical subtraction, it should have a line underneath it. Okay. Now this is something that I'm going to hammer home a lot, is get your line underneath the entire equation because it's really both sides you're subtracting 5 from. So it's x plus 5 minus 5. It's 12 minus 5. So the line should go under all of this, even though it's the plus 5 and the minus 5 that are going to cancel. And so this right here then is the first step of your work. That's really the first step of your work. And so when we see a step of our work, we should see ourselves using a property. So what property do we see being used here? Well, we're subtracting something on both sides, so this is the subtraction property of equality. And then once we've used that step, I then want to find the result, the resulting equation. So it's going to be copy the problem, which will be an equation. Our step will show a property being used. We're subtracting 5 on both sides. And then the resulting equation will be, well, let's clean this up now. So plus 5 minus 5 will cancel each other out. So the only thing left over here is the x. On the right side, 12 minus 5 is 7. Now your justification will be, well, you just use the subtraction property of equality, so now we want to simplify it. Okay. So let's look at the next example. Go ahead and skip a couple lines just to give a little breathing room there. X minus 7 equals 8. We're going to take a look at how we'll show our work for that. So this is our copied problem, copied equation. It is the equation that was given to you. And then I want to do my first step, which is going to show a property being used. And as we discussed on the front, since it's a minus 7, in order to get rid of that minus 7, we're going to do the inverse. And we're going to add 7 to both sides. So plus 7 on both sides. Now since this is vertical addition, just as we've always done, we're going to put a line underneath that. And so when I put a line underneath that, this is now the addition property of equality that we're using. And so I want to now find the result, which will be a new equation that will also be equal. I want to find that by simplifying. So minus 7 plus 7 cancel each other out because they're inverses. So that means x is the only thing left over. And then 8 plus 7 is 15, just like we had in the front. And so when we're doing this on the homework, that's what our work is going to look like. So we're going to try to keep moving quickly here. So 3x equals 36 was our next equation. So we want to copy the equation, the given equation, and then we want to do our first step using a property. So in this case, our first step, since we are multiplying 3 times x, we want to divide both sides by 3 to cancel out that times 3. And again, we still use fractions, but we just don't bother rewriting the original equation. We just go ahead and put fraction bars under each side and turn them both into their own fractions. And so what are we using here then? Well, fractions mean division, so this is the division property of equality. Now remember, the division property of equality has that one extra condition that you've got to meet. You've got to have an equation, but you also need to make sure that what you're dividing by is not 0, which we're fine. We're not dividing by 0, we're dividing by 3. All right, and so now I want to find the resulting equation by simplifying what we just wrote. So 3 times x divided by 3, the times 3 and the divided by 3 will cancel. That leaves me with just x. And then 36 divided by 3 is 12, just like it was on front. So that's what our work should look like. Now, one thing you'll notice here is the fraction bar was here. Do we normally underline our fractions? No. So is there an underline here? No, there isn't. So really the underline just comes in with addition and subtraction. And then with division, we have a fraction bar. Which leads us to our last equation from the front. X over 9 equals 6. So x over 9, we want to copy the equation, and it is here because it's the problem that was given to us. And then I want to take my first step, which will be based on a property. So if fractions mean division, then in order to cancel out that division, we're going to multiply. Now, multiplication is an unusual one because vertical multiplication uses the x for multiplication. And we can't use the x for multiplication because now x is being used as a variable. And so what we end up doing for multiplication is we do have to rewrite the equation. But we multiply both sides with a times dot by whatever number you need to. So you're going to copy the equation, and then in your first step, you're going to recopy it, but with your property being used. And so in this case, it's the multiplication property of equality. So this one actually ends up looking a lot like the front. And so now we want to find the resulting equation by simplifying. So a times 9 and a divide by 9 will cancel, leaves me with just the x, and 6 times 9 is still 54. All right, we're going to take a look at just two more examples quickly, and I'm not going to do quite as much writing for these. So for the next one, we're going to take a look at 2/3 x equals 18. And this one's a little unusual because when you look at this 2/3 times x, you'd say, all right, what's the inverse operation of multiplication? Well, that's division. So you would think, all right, let's divide both sides by 2/3. Now here's the problem. Do we divide by fractions? Not typically. So instead of dividing by a fraction, in algebra, we typically instead multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. So just to make a little note about what we're doing here, if you have a number divided by a fraction, that's going to be equal to that number times, oops, make sure I spell that right, times the reciprocal. So do not divide by fractions. Do not divide by fractions. So over here to solve this, if we were to justify our steps, this then would be a multiplication property of equality. So just a quick shortcut here though, when you have a whole number times a fraction, little shortcut here is you're going to take that whole number, and then when it's times the fraction, you're going to multiply your number with the numerator. You're going to divide your whole number by the denominator. And you can do that actually in any order that you want. So when I look at this here, I would actually do 18 divided by 2 first and get 9, and then times the result by 3, so 27. Over here, reciprocals will cancel each other out, become 1, and then 1 times x is just x. So if you have a fraction, that's what your work should look like. All right, and then ultimately, ladies and gentlemen, we are building up with this. Go ahead and skip 3 lines here. We are building up with these skills to eventually start combining them. So we want to ultimately combine these skills where we'll be using the acronym SADMAP. SADMAP, which is just PEMDAS backwards, to tell us what order to do things in. So if we kind of think this through, the first thing we're going to do still is going to be to copy the equation down. And then I want my first step, which is going to be to use a property. So we've got a times 2, so we're going to have to divide both sides by 2 at some point. We got a minus 5, so we're going to have to add 5 to both sides at some point. But which one should we do first? Should we do the divide by 2 first, or should we do the add 5 first? Well, SADMAP tells us to do the add 5 first. So I'm going to add 5 to both sides first. And now I want the resulting equation of that first step. So minus 5 and plus 5 will cancel each other out. That'll leave us with just 2x. 19 plus 5 is 24. And so now I want the next step, the second step, which again is going to be to use a property. So this time, to get rid of the times 2, the inverse of that would be to divide both sides by 2. And then I want the resulting equation from that step. So times 2 divided by 2 will cancel, leaves me with just x. And then 24 divided by 2 is 12. And that's what we're working up to. And that is the end of our lesson.